Example 12 using scientific notation. We're going to perform the operations and write the answer in scientific notation. In this case, we're taking a scientific notation number and multiplying it by another scientific notation number. So we have 8.14 times 10 to the negative 7 times 6.5 times 10 to the 10th. We're going to take 8.14 and multiply it by 6.15 because those are the values for the A. And then we're going to take the base of 10 with the powers. So we're going to take 10 to the negative 7 times 10 to the 10th. So the commutative and associative properties allow us to be able to use that. So now if we take 8.14 and multiply it by 6.5, we get 52.91. And remember that if we multiply with the same base, we need to add our exponents. So negative 7 plus 10 is positive 3. So we have 52.91 times 10 to the third power. Now, 52.91 is still not in scientific notation because we need a decimal place to be in between the 5 and 2. So since we're moving it to the left, we have to add 1. So we end up getting 5.291 times 10 to the 4th. Next, we have 4 times 10 to the 5th divided by negative 1.52 times 10 to the 9th. So now we're doing division. So we're taking 4 and then dividing it by negative 1.52 times 10 to the 5th divided by 10 to the 9th. Now 4 divided by negative 1.52 gives us a number of negative 2.63. And 10 to the 5th divided by 10 to the 9th, remember that if you have the same base and you subtract them, when you have the same base, you subtract your exponents. So therefore we have 10 to the negative 4. Now since the decimal is already in between a 2 and 6, we don't need to go any further with it. So the answer is in scientific notation, negative 2.63 times 10 to the negative 4. In part C, we have 2.7 times 10 to the 5th times 6.04 times 10 to the 13th. So we're going to take the two numbers, 2.7, and multiply that by 6.04. And then we have 10 to the 5th times 10 to the 13th. Now 2.7 times 6.04 is 16.308. Remember, if you multiply with the same base, we add our exponents. So 5 plus 13 gives us 10 to the 18th power. Now again, it's not in scientific notation yet because we need to move that decimal place to be in between the 1 and 6, which means we'll only need to move it to the left 1, which means we're adding 1 to the exponent, which then gives us the scientific notation number 1.6308 times 10 to the 19th. In part D, we have 1.2 times 10 to the 8th divided by 9.6 times 10 to the 5th. So we have 1.2 divided by 9.6 times 10 to the 8th divided by 10 to the 5th. Now 1.2 divided by 9.6 gives us 0.125. 10 to the 8th divided by 10 to the 5th gives us 10 to the 3rd power. Now in this scenario, this decimal point needs to be in between the 1 and 2, so now we have to move this to the right 1 place. Since we're moving it to the right 1 place, we're going to subtract 1 from the 3. So we end up getting 1.25 times 10 to the 2nd power. In part E, we have 3 scientific notation numbers. So we're going to take the three numbers at the beginning, so 3.3 times negative 1.05 times 5.62 to give us negative 19.65. And then we're going to take the powers of 10, so 10 to the 4th times 10 to the 7th times 10 to the 5th, meaning that since we're multiplying all the same base, we're adding our exponents to get 10 to the 16th power. And so we want to make sure this is not scientific notation, so we're going to move this decimal place to the left 1, which means we're adding 1 to the 16, which then gives us negative 1.965 times 10 to the 17th power.